The rise of AI in the last few years has brought about some incredible technological achievements. But the thing is, these AIs only know so much. What if you could teach an AI whatever you wanted and then be able to use that model later on? Now, what if I told you that was a reality? Because with Gradient, you can do that. Gradient is a platform that allows you to easily fine-tune existing base models using a very simple API. So they provide the base models for you, they train them using their own data sets, and then you can provide your own data and perform something called fine-tuning on top of that. Fine-tuning is a concept in AI that has existed for a long time, and it involves taking a standard base model that's already been trained on a very large data set with a very general overview of data and fine-tuning it to specialize it to a particular thing, or just to be able to teach it more things on top of that. So one way you can think of it is by thinking of a school. You go to school and you learn a very broad range of subjects. But as the years go on and you go into higher education, you narrow the subjects that you take down to specialize in what you want to do. So for example, I did subjects in computing and maths and ditched all the others. And this is sort of what fine-tuning is. So you have the base data and you're giving it more specific data to fine-tune it or specialize it to perform a particular task in a particular way, or to, obtain knowledge that it didn't have previously. On top of being able to fine-tune LLMs, Gradient also provides a few other benefits that I want to talk about very quickly. So the first of which is that they handle all the infrastructure for you. Everything's done in an API and you send requests to their AI cloud, which handles all the training, all the running, all the querying, everything. And that's all possible with zero latency and per token pricing. And Gradient is the only company to be able to do that. They're also very big on open source. So all the base models that they have are open source. All the fine-tuned models that you create are open source, so you can go in and have a look at them all you want. And it also means that you can own what you create. And because of that, you can modify or remove it whenever you want, providing you full control over what you create. So now I'm going to show you how to actually use Gradient to fine-tune LLMs. So first, you'll need to create an account, so you can come to gradient.ai and click this sign up button. I already have an account, so I'm just going to log in. And you can see you get taken to this workspace page. Now, I already have a workspace. You'll be prompted to create a new one, but you'll need to create a workspace and make a note of this workspace ID. After that, you'll need to go to account up here, click access tokens, and generate a new token. I'm not going to create one on the video because I already have one, and I am going to be revoking all access tokens I show on this video before it goes live, so don't even think about it. But once you've done that, you can go back over here into your codes editor. You can create a .m file up here and put in your gradient access token as such and your gradient workspace ID as such. And then we can load them later down the line once we actually start training and running our models. So first, you will want to pip install Gradient AI. And then we also want to install python.env as well. So Gradient AI is the Python SDK that Gradient provides. They do have an API, just a raw API that you can use if you want. They do also have a command line interface tool, and they do have, I believe, a Node.js API or SDK as well. So they have a few options, but I'm going to be doing this in Python, obviously. And then our python.env just allows us to load various things in this .env file. So we can do that. And in this video, I'm going to be showing you how to do that with Gradient. So first, you'll need to create an account. So you can come to gradient.ai and click this sign up button. I already have an account, so I'm just going to log in. And you can see you get taken to this workspace page. Now, I already have a workspace. You'll be prompted to create a new one. But you'll need to create a workspace and make a note of this workspace ID. After that, you'll need to go to account up here, click access tokens, and generate a new token. I'm not going to create one on the video because I already have one, and I am going to be revoking all access tokens I show on this video before it goes live, so don't even think about it. But once you've done that, you can go back over here into your codes editor. You can create a .m file up here and put in your gradient access token as such and your gradient workspace ID as such. And then we can load them later down the line once we actually start training and running our models. So first, you will want to pip install Gradient AI, and then we also want to install python.env as well. So Gradient AI is the Python SDK that Gradient provides. They do have an API, just a raw API that you can use if you want. They do also have a command line interface tool, and they do have, I believe, a Node.js API or SDK as well. So they have a few options, but I'm going to be doing this in Python, obviously. And then our python.env just allows us to load various things in this .env file. So we can do that, and I already have everything installed, so it's not going to install anything new. And then we are going to create a new file called run.py. And I'm just going to show you first how to, use the Gradient client that they provide to create a model using the base model and query it using certain things before we get into any of the fine-tuning stuff. So if we do from.env import load.env and from Gradient AI import gradient, and this is our client. If you then do if name double equals main, we do our load.env, so we just call that, and that loads everything in this .env into environment variables. And then we can do with gradient as client. You can, if you don't want to use environment variables, you can provide the access token and the workspace ID into the client itself. But it also supports using environment variables, and all the examples in the documentation go down that road. So I reckon it's probably the better way to go. From there, we can simply create a model, and we can do that using client.get base model. And we need a base model slug. Now, to get access to the base model slug, we go back to the website, and if I just go to the home page, and then if I just go to it through here, and then the docs, guides, and then models, and if I zoom in, this is where we can find out what models Gradient currently supports. So it supports 3. It supports the Bloom 560, the Llama 2, and the News Hermes Llama 2, which is a fine-tuned version of the Llama 2. And we have these slug IDs down here, and these are what you need to pass to that function. So if you want to use the Bloom 560 model, you'd pass this. If you want to use the Llama 2 7 billion parameters, you'd pass this. If you want to use the fine-tuned version with 13 billion parameters, which is the one that we're going to be using, you want to pass in this. There's also a few extra models that will be supported in the future, including one with 70 billion parameters, which is pretty crazy. So that's actually very exciting. But for now, we're going to just copy paste News Hermes 2 or Naus. No, I'm not even sure how you pronounce that. I don't even know if I'm pronouncing it correct. I'm going to continue calling it News Hermes, and people can correct me in the comments if they want to. And then we're going to print loaded model with ID, and we're going to pass the model.id, and then we're just going to use a string representation with that. And then we're going to create a very simple command line interface to be able to query the model. So we can do while query walrus operator import or input, sorry. So each line will have an input, and if we actually provide something to that input, it will do, it will, continue on. If we don't provide anything, if we just leave it blank, it will exit out, but you can just use Control-C. We'll do completion equals model.complete, and then we want to provide the query, and you want to provide this if you use one of the Lambda, if you use one of the Llama models, you'll want to use kind of the Llama template, which I'll talk a little bit more about later. But the general idea is that you have an instruction, which will be the query, and then a double new line, and then you have triple hash response, and then the AI will be, tasked with filling it out from there. So this is the recommended way of doing things in Llama. You don't have to do it, but it's just the way that it wants to. And then we are actually going to specify a max generated token count. We're going to set it to 200 for now. I believe the default is 100 and the max is 500. So And then we're going to print completion dot generated output end equals, and then that. And then if we do py run.py, So we can see that we've loaded a model with the ID. This is just the idea of it. And then we can pass a question. So what's the biggest planet in the solar system if I could type? And you'll see once it gets back, obviously these AIs take a little bit, but they're not actually super slow. That was very quick. Jupiter is the biggest planet in the solar system, which is correct. It knows what Jupiter is. That is good to know. What if I asked it about myself? Cabra YouTube channel. Now, OpenAI's ChatGPT doesn't know who I am, and Llama 2 by default also doesn't know who I am. It has absolutely no idea. It tries to guess, and it will normally say one of two things. Yeah, so it says Cabra's a YouTube channel that focuses on creating content related to cars and automotive lifestyle, which is not true. That channel does not exist. However, that's not really a problem because we can just teach it by fine-tuning. So that's what I'm going to do now. I'm actually going to turn that off, just in case it does anything random. So I'm going to create a file called train.py, and then we're going to import JSON. We're also going to from.env import load.env again, and then we're going to from gradient AI import gradient, and then we are going to, that's it actually, we just need those three. And then we're going to set a number of epochs, and we're going to set that to 5 for now. And then we have our run guard with gradient. Oh, we need to load.env actually to load our environment. And then we do the same thing with gradient as client. So anything you want to do with gradient, you would start with that line. You don't have to use it as a context manager, but it just makes sure that you close the client at the end. And then we, once again, are going to supply or say to get the base model, and then our base model slug is going to be news Hermes 2, because that's the one we want to fine tune. However, this time we want to create an adapter, and we're going to do that using model.createModelAdapter, and then we can give it a custom name. So I'm going to call it Cabra just tutorial, I suppose. And this adapter is what we're going to fine tune. So the model is the base model, and the adapter is our fine tune model on top of it. And then we're going to print created adapter with ID, and then adapter.id, and this we are going to need to make a note of, so do keep this in mind. And then we have actually a series of samples already here. So if I just get rid of that for a second, we can see that I have a number of inputs. So I have 3 in particular, all in the Llama templating again. So you have the triple hash instruction, and then the question. And I think the space might be optional, but every example I saw had it there, so I daren't risk it. Then we have 2 new lines, and then we have triple hash response, and then a response here. And these are, dict value or key value pairs where the key is always inputs and the value is always, this string. It is then a list of these dictionaries. And you can have it in a JSON file if you want. You can also just have it in a dictionary in the code. I felt it's just easy to put them in here because we can just load them in. So if we do samples.json, and I will quickly say before we go into it, that these samples are intended to teach the bot who I am. So you have who is Cabra, you have what content does Cabra produce, who runs Cabra, and then you have various bits of information. So for example, Cabra is a programming YouTube channel primarily specializing in Python content. And these are, somewhat detailed. They're not super detailed. They'll be sufficient because the model is actually able to learn pretty damn quickly, which is cool. We have samples equals json.load and then f. So that will just load our samples into a dictionary. And then we want to do for epoch in range 1 epochs plus 1 prints fine tuning. And then we will have the epoch it's on. So epoch out of epochs like that. And then we want to do adapter.finetune samples equals samples. So this is how you fine tune a model. It literally is just that one line of code. Of course, you probably do want to do epochs like this because the model will, learn better. If you just do it with one epoch, it's probably not going to learn anything. Just be careful with the number of epochs you provide, as fine-tuning a model still has the overfitting problem that just normally training a model does. So if you provide a number of epochs that's too high, it will start to overfit, and then performance will get worse. Again, so there is kind of a sweet spot. 5 is probably too low, but we're just doing it for example's sake here. And then we just print done to show that the script is done, and then this will train our new model. So if I do py train.py like this, so you create an adapter with ID this, and I am actually going to copy paste this because we will need that. Oh, I've just pasted something. I hit the wrong button there. I've totally not been using computers for like 2 decades. Getting Control-C and Control-V confused. But you can see it's fine-tuning. So each of these fine-tuning, it's learning more about what I've told it, which isn't that much. Ideally, you would want more data than this. But again, this is just an example. And it is, if anything, an example just to show you how much progress it can make, even on this limited data, which is actually very cool. While it is training, actually, we can go back and we can tell the model to use, or we can tell our run script to use the model we want. It's done now, so we can just close that and do this. And we want to, instead of using this line of code in our run, we just want to do model equals next, and we want to do a filter and specify lambda m, which is the model object, and then we want to do m.id double equals sys.argv1, and then I'm going to provide sys. I'm essentially just doing this so we can provide the model ID in a command line argument. You don't have to do it this way if you don't want to. And then we want to pass client.list models only base equals false. So if you provide only base equals true, it won't return out any of your custom fine-tuned models. If you provide only base equals false, then it will return all the base models and all the fine-tuned models that your account is associated with. I'm actually going to make sure that's on another line. And then we'll load the model like that, and then we will query it, and we will see if it's able to work out who I am. So if we do py run.py, and then we'll pass that in there, it loads it. And if I say, tell me about the Cabra YouTube channel, it should now be able to work out who I am, or it should at least have a much better idea of who I am once it gets back to me. There we go. So it's come back and it now says that Cabra is a YouTube channel dedicated to teaching Python, which is correct. It also says the channel is run by a software engineer named Alex. It's sort of confusing the information a bit. This sort of thing would indicate that you would probably need maybe a little bit more data, or maybe a little bit more training time to actually get there. We are, giving it a very pitiful amount of data, so I'm not surprised it's got a few things wrong. But you can see how much progress it's made in just that data and just that time frame. And this is the power that gradient gives you, and this is the ease that it gives you to do it, because it is literally just, we've done this in like 10 or 15 minutes or something, and we already have a model that is now, it now knows who I am. And the best thing about this is that because these LLMs are all very smart and very powerful, you can get a model, even one of the gradient ones, you can pass this into it and you can tell it to then generate a larger data set based on what you've provided here. And you can get your own model essentially to create the data to train itself. And then it's at that point it's the self-fulfilling prophecy, and that that's the power of these AIs. They can do anything you want them to do. And that's just a really simple example of the sort of stuff you can do with fine-tuning LLMs. They have a huge base knowledge already, so they already know a lot of stuff. But you can, as I've shown here, teach them something new. You can also expand their knowledge in a particular field that they may already know. You can kind of specialize them down to just talk about that. So if you wanted an AI that knew everything you wanted to know about literature or whatever, you could do something with that. You can also, if you really wanted to, train it to talk a particular way. So if you wanted it to talk like your favorite character out of a TV show, then you can do that. You can easily do that just with enough data and enough training time. You can get it to do whatever you want. So the possibilities are pretty much endless. If you like what you've seen here, then make sure to head down to the description. In there you'll find a link where you can sign up to Gradient and get $5 worth of free credits, which is more than enough to have a good play around with the system and kind of get a feel for it and all of that. If you like the video, then make sure to leave a like to let me know, and maybe subscribe if you want to see more videos like this. If you have any questions or ideas of content you want me to do, make sure to leave a comment in the comment section below. I read every single one, so your feedback is greatly appreciated. I'd just like to take the time to thank my amazing patrons and members on screen now. £1 a month and you can be on that screen as well. And I will see you in the next video where we talk about the upcoming plans for Python 3.13. So if you're excited about that, you don't want to miss it.